All right, today we're diving into a brand new open source AI that's really making some waves, Kimi K2. We're going to crack open its technical report to figure out what makes it tick. We're talking its unique architecture, its super innovative training process, and why this thing represents a major leap forward for AI. And right out of the gate, the report makes this huge claim. They're not just trying to build another large language model. No. The goal here is to push towards something they call agentic intelligence. And trust me, that's not just a cool-sounding buzzword. It's a fundamental shift in what we should expect an AI to be able to do. So what is agentic intelligence, really? Well, the best way to think about it is the difference between having a tool and having a teammate. It's an AI that doesn't just wait for your prompts. It can actually perceive a situation, come up with a plan, reason through all the steps, and then take action, all on its own. This one core idea drove every single design decision for Kimi 2. Okay, so to build an agent, you've got to start with a seriously powerful brain. So let's begin with the absolute foundation of Kimi K2, its ultra-sparse architecture. Let's break down exactly what that means. The first number that just jumps off the page is its sheer scale, 1.04 trillion parameters. Now, parameters are basically the knobs and dials the model tunes as it learns from data, and a number this big puts Kimi K2 right up there in the top tier of AI models. But believe it or not, that huge number is only half the story. Because here's where things get really, really clever. Even though it has over 1 trillion total parameters, for any single task, the model only activates about 32.6 billion of them. That's the sparsity in action. It's like having a gigantic library, but instead of reading every book for every question, you instantly know which specific few you need to pull off the shelf. So how on earth does it do that? This secret sauce is something called a mixture of experts, or MoE architecture. You can picture it as this massive team of 384 different specialists, and each one is a world-class expert in its own little area. So when a task comes in, the model has this internal router, like a project manager, that doesn't bother everyone. Instead, it intelligently picks the absolute best 8 experts for that specific job. This makes the whole system incredibly efficient without sacrificing any of its power. And when you compare it to a similar model like DeepSeek V3, you can really see the genius in their design. Look at this. They dramatically increase the number of experts, from 256 all the way up to 384. But to pay for that, computationally speaking, they did something clever. They cut the number of attention heads in half. Attention heads help the model weigh the importance of different words. So the trade-off here is strategic. They chose more specialized experts over broader general attention. It's all about boosting performance while keeping things lean and efficient. So you've built this massive, sparse model. That's one thing. But actually training it? Well, that's a whole different beast. And that brings us to the next chapter in this story, the absolute ordeal of pre-training, where this model had to digest a mind-boggling amount of data without, completely falling apart. This is the million-dollar or maybe trillion parameter question the Kimi team had to solve. See, when you're training at this kind of scale, things can go sideways fast. A really common problem is something called exploding attention logits, which is just a technical way of saying the internal math of the model goes haywire. The numbers get way too big, and the whole thing just becomes unstable and starts spitting out nonsense. The team was stuck between a rock and a hard place with their choice of optimizer. That's the algorithm that helps the model learn. On one hand, you have the MuonClip optimizer. It's incredibly token efficient, meaning it learns way more from every single piece of data. The problem, it's notoriously unstable. On the other hand, you have the good old Atom W optimizer. It's stable as a rock, but it's much, much less efficient. They needed the best of both worlds. And their solution? Well, they invented something new. They called it MuonClip, and the name tells you everything. It takes the raw power and efficiency of the Muon optimizer and bolts on this brand new stability mechanism called QK-Clip. This was the key that finally unlocked stable training at this massive scale. So how does this thing actually work? It's basically a two-step dance. Step 1 is the normal, super efficient update from the Muon optimizer. But step 2, that's where the magic happens. The QK-Clip mechanism is always watching the model's internal scores. If any of them start to get too high, past a certain threshold, it just kicks in and gently rescales the model's weights. It's basically a safety harness that pulls the values back into a safe, stable range before they have a chance to explode. So simple, but so brilliant. And the result of all this clever engineering, You're looking at it. Just flawless stability. The report proudly states that they trained Kimi K2 on 15.5 trillion tokens with zero, not one, loss spike. That is a massive engineering achievement and a huge testament to how well MuonClip works. Okay, so we've got this incredibly powerful and stable base model, but it's still just raw potential. Now it's time to teach it how to act. This next stage, post-training, is all about transforming that raw horsepower into a capable agent that can actually use tools and reason its way through complex problems. To do this, they built this absolutely incredible data pipeline. You can think of it like creating the ultimate virtual training ground for an AI agent. First, they built a massive library of over 20,000 digital tools. Then, they designed agents and all sorts of tasks that would require using those tools. And finally, they just ran simulations of the agents completing those tasks, which generated tens of thousands of perfect step-by-step examples for the model to learn from. And to really sharpen its skills, Kimi K2 uses a super smart reinforcement learning system, learning from trial and error with rewards. For tasks that have a clear right or wrong answer, like a math problem, it gets what are called verifiable rewards. Simple. But for more subjective things like creative writing, it uses a self-critique rubric reward. This is amazing. The model literally learns to grade its own work against a set of rules, basically teaching itself what kind of answers humans actually prefer. So, after all that, the unique architecture, the groundbreaking training, the agentic fine-tuning, how did Kimi K2 actually do? Let's check out the report card. First up, SWE-Bench. This is a really tough test of real-world software engineering skills, and Kimi K2 pulls in an impressive 65.8. That score beats a lot of very well-known models and seriously closes the gap with some of the top-tier closed-source models like Claude Opus. And the story gets even better on Live Code Bench, which is all about competitive coding. Here, Kimi K2 actually leads the entire pack with a score of 53.7. It's outperforming every other model, both open source and proprietary. That's a clear sign of its practical coding abilities. And this right here, this is where all that agentic training really pays off. On SWE-Bench, which is a test designed specifically for tool use, Kimi K2 scores a 66.1. It's not just a little better, it substantially outperforms all the other models, proving that it has really mastered that core agentic skill of using tools to solve problems. So, what's the bottom line here? Kimi K2 isn't just another model thrown onto the pile. Through its smart architecture, its incredibly stable training, and its laser-focused agentic tuning, it has set a brand new state-of-the-art for what an open-source AI can do, especially in those really complex, action-oriented areas like coding and tool use. And that leaves us with this one really exciting question. The power to build these truly autonomous AI agents, it's not locked away in some private lab anymore. It's out there, available for everyone. This achievement opens up a whole universe of possibilities, from completely automated software development to personal assistants that are actually helpful. So the real question is, what comes next? What will you build with it?